All right. Good morning, afternoon, evening, wherever you're joining us from around the globe. Welcome to NestGen 24. This is a place where the future of drone autonomy takes flight. Now, today, we're embarking on an exciting journey into the world of flight safety and compliance for BVLOS operations. Now, BVLOS represents the frontier of drone technology. Now, it's pushing the boundaries of what's possible in uncrewed aviation. So in this session, we're going to dive deep into the heart of flight safety, exploring the latest advancements and regulatory insights that are shaping the skies of tomorrow. Our panel today consists of some of the most forward-thinking minds in the industry, experts who live on the cutting edge of technology, policy, and operational safety. Now, they're here to share their knowledge, experiences, and visions for a world where drones do more, see further, fly safer, all while ensuring compliance with the evolving global standards. So before we dive into their introductions, let's cover a little bit of housekeeping. One, we really got to thank the event sponsors, DJI Enterprise and Sunflower Labs. Very excited to have them here. I would say one of the things that we're also going to do, we're going to take questions. We're going to leave them at the end, so you can use the Q&A section to add those questions, and we'll get to them at the end. And let's see. This is being recorded, so if there's got a little bit of lag for you, you want to see it later, show your friends, show your family, show your cat, whatever you want to do, it's going to be available for you in a few short days. So without further ado, I'd like to turn the floor over to our distinguished panelists. Please introduce yourself and let's dive right in. Let's start with Ian.
Hey everyone, my name is Ian Nace, founder and CEO of Zing Drone Solutions. We're a drone solutions provider who has been working in the drone delivery space, and more recently, we launched 2 FAA DOC approved remote ID broadcast modules that we're bringing to the market, and excited to discuss how that might tie into BVLOS operations.
Thanks, Ian. Let's move to Josh.
Hey everyone, my name is Josh Ogden. I'm the CEO of AVSS. We build parachute recovery systems, flight termination systems, and guided delivery systems. We're really good at dropping things from the sky.
Awesome, great intro. Let's go to last, but certainly not least, let's go to Don.
Hi, I'm Don Birchoff. I'm the CEO of True Weather Solutions. We're a micro weather data and analytics company focused on low altitude weather data gaps and really bringing solutions for BVLOS operations where there's no longer a pilot on the aircraft, and we try to fill in that gap. And we also help to lead the ASTM weather standard that's been published and will allow for lower cost weather sensors in the future to be used in flight management decisions.
Awesome. Thank you so much. I'm just really honored to have all 3 of you on this panel today. So I want this to be fairly conversational. Let's do this, though. I want to ask each of you a question that's been tailored for you. And then hopefully we're going to get some other questions, and we're going to kind of tackle this from as many perspectives as possible. So let's go to Ian. So Ian, in your perspective, what are the sort of primary challenges in scaling remote ID technologies for BVLOS across different urban environments, and how can these challenges be overcome?
Yes, so great question. I'll start it off by giving a little bit of history about remote ID. So as many of you know, remote ID was initially proposed back in 2019 with the final rulemaking coming out in 2021. And now we're into the phase where basically implementation is required. So there was the extension on the remote ID requirement for broadcast modules until March 16th, which is exactly 3 weeks away from today. So starting on March 16th, effectively everyone in the United States airspace system is required to have a remote ID broadcast, whether that's standard remote ID built into the drone or a remote ID broadcast module that is on one of the more legacy models. So the way that I see the main challenge with it right now is the way that remote ID was initially proposed back at the start was both a network-based and a broadcast-based system. That has shifted due to the 53,000 comments on the rule to a purely broadcast-based system and no longer a network-based system that was more part of the UTM, where all UAS service suppliers would be able to have that remote ID information and know where all drones are in real time. But while it is just a broadcast-based solution now, we at Zing believe that there's solutions that can be tied in to basically enable more BVLOS operations. So the way that we think of it now is that all drones are now digitally visible when before they were not. So every single drone, similar to like the ADS-B system for manned aircraft around 30 miles of an airport in that Mode C veil, all drones can now be seen within a certain vicinity of one another. So if a drone is actively broadcasting via Bluetooth and Wi-Fi, its exact GPS position, and also the pilot's location, we can now pick that up from scanners, either onboard scanners on other drones or scanners on the ground that are picking up remote ID information in nearby vicinity. So I think that one of the main challenges has been the elimination of the network-based remote ID requirement and coming up with solutions to still enable BVLOS in the way it was initially envisioned in the UTM system.
Great, Ian, thank you. I got more questions for you, but let's move on to our next panelist, Josh. So I'm curious, so from your perspective, and this one's directly tailored to you. So what are the latest advancements in flight termination systems for drones? And how do they specifically cater to the unique challenges of BVLOS operations?
Yeah, so flight termination systems are an interesting topic from a perspective of do they or do they not include a parachute? So there are rules that you don't necessarily need a parachute. The Irish, for example, will tell you you don't necessarily need a parachute, but they do actually like it because of human factors. You don't want your drone's drifting away to an airport. You might, be hesitant to drop that 50K out of the sky if there's no secondary device. Even though a parachute doesn't guarantee your drone doesn't break and make sure that no one gets hurt, but there's still the psychological human factor. With flight termination specifically, the whole intention is stop the motors from spinning. Two purposes. One, avoid entanglement. That's like a nice to have. The real purpose is bystanders. We don't want drones coming down, with blades spinning and hurting someone. And so the big pieces of flight termination systems, you've got your ArduPilot PX4 where you can send a shutdown command. You've got independent systems that are turning off power of the drone or are focused directly at segregation so that if the drone fails, you can still trigger it. I don't believe flight termination systems from a physical standpoint, blocking propellers is a good idea because you actually end up breaking a propeller and now you have a new laceration point. So the big pieces of flight termination systems we see coming forward is more about the independence. And you see that with something, enhanced containment and certain regulatory pieces. The big problem, I think, with the latest advancements is getting drone manufacturers wrapped around the requirements. Everyone wants to use that off the shelf, just click the button and not understanding the failure points. And so really the latest advancements are focusing on how do you make sure that the system still works when the drone isn't working, which seems pretty intuitive because you only want to kill a flight when the drone's not acting right.
That does make intuitive sense, but if common sense was a thing, then I don't know.
We wouldn't have a business, so that's
yeah,
okay.
I kind of think so. Thank you, Josh. Coming to you, Don. Got one tailored right for you. So how can real-time weather tracking and forecasting technologies, how do we integrate those into BVLOS drone operations? How do they enhance flight safety and decision-making?
Well, first of all, I don't know if folks realize, but about 30% of manned aviation or crewed aviation today that's canceled or delayed due to weather could have flown. And so we have a lot of uncertainty out there that's causing people not to fly when they can fly. Now, when you look at that's revenue that's being dropped on the ground. And the current aviation weather systems we have were not built for low altitude weather. There is no data being collected in most places, about 97% of the country and around the world. There's no data being collected below 5,000 feet that will actually benefit you today. It's only at airports and it's some balloon launches. Everything else you see is a model, and the model has errors in it. So what True Weather is focusing on is how do we close those gaps where it matters? How do we get you safer, but more flight time? Because safety is a direct, relationship to your decision making about whether there could be an incident. If you are uncertain about the weather, then you're probably going to be more conservative, and you don't want to have an accident. So what we're doing is saying, look, we can get you back that 30% if you have the right infrastructure associated with your systems. Now, when we're doing VLOS, it wasn't as big of an issue. But now what we're seeing is more drone-in-a-box solutions for autonomous flight, and there's no visual observer, or there's nobody outside even with the drone. People are working inside flying these drones. They're not even in the weather. They don't know what's really happening out there. So what we want to do is close the gap and then bring that data into our API, which then can be fed into your systems. And you can have very low cost sensors. We're talking like $1,000 for a wind sensor on a tower that's co-located with a detect and avoid radar. That can give you unimaginable information about what the winds are doing at altitude. And then you can also bring in a low-cost ceilometer or weather station in the municipality that will give you the ceiling and visibility right in your municipality, because the METAR may not be relevant. And we can bring that into our system and integrate it into all these decision systems. And so that's what we're doing. And we've worked with ASTM. We developed a standard because today the main concern is it approved weather? And up to this point, approved weather was only government data, and it was only the METAR. But does it make sense to use the METAR that's 15 miles away to make a decision about what you're doing? I've told the government that that's actually it's malcontent, right? You're giving people the impression that that's a good piece of information. And so they've agreed, and they said, look, we're going to have the standard. So the standard's been published, and the standard's going to become an advisory circular, and it's going to become part of 108 in the future. And so as we're working through the DFR and the BVLOS, whatever your entity is, bringing weather resiliency in is a very low cost compared to all the other money you're spending for infrastructure. And what it could do is get you more flight time and make you more safe.
Don, you teed me up perfectly, and thank you. That insight was very helpful. We're looking forward to seeing that coming out in advisory circular. Absolutely. Mm-hmm. So this one's for the group. So you teed up standards, Don. So I'm gonna dive into standards. So like what this is for everyone, and you can start. What are the key barriers to establishing and adhering standards? And then more importantly, I'm interested in a global standard for BVLOS drone operations. And how do we overcome and address these barriers?
You know me, I'm always ready to answer if you want me to start.
Yeah, let's start with you, Don.
So the barriers that we had in weather. So I'm very proud of the fact that I think the weather industry and the work we've done with the FAA and now doing with the ASA and others, we're kind of leading in how you can take a standard, develop a standard, work with the CAAs, work with the ANSPs to figure out how to implement that standard. And so the challenge always is you can write a standard, but how are you going to execute it? What are the means and methods of compliance that are going to be required? And how do you get that out into a rule that everyone can follow and is affordable? So one of the things that we said was we don't want to drive cost up. What we're trying to do is bring a solution that's going to actually, free weather data sounds free, but it's not. It's costing you 30% of your flight time. I think I made that case earlier, right? So it's not really, it's free. You think it's free, but it's costing you money. How do we close that gap, get something affordable out, and make sure it's meeting the standard? Because weather has always been very regulated in the aviation industry for a reason. And that's because you don't know what you're using on an app or wherever you're getting it today. It could be spoofed. It could be cyber insecure. It could be unreliable. We don't know what you're getting. The FAA and all the other national, the CAAs have said we have to have controlled weather because we have to know where it's coming from. And as we move into the autonomous era, there's not going to be humans in a loop anymore. So you're not going to be checking that data. So that data has to be checked in some way. So the standard has to be executable, has to be affordable. It has to have a business case that is making sense. And then you got to test and demonstrate it. And that's the hurdle, right? The hurdle is how do you test and demonstrate and get something feasible that will work? And I think that's one of the biggest challenges.
Makes sense. Josh, I'd like your perspective.
Yeah, so I think when we look at the challenges, there's like especially with the products we make with the parachutes and flight termination systems, we've seen the challenges come to terms. I guess manufacturers and end users come to terms with it. I think end users did first. I think they realized, hey, I just want to do this mission. What do I need to buy? And then I think with manufacturers, what we see is, and I would say there's an opportunity there when it clicks and they realize it is, they look at the product, for us as like unnecessary. It's extra weight, extra cost. It's a new failure point. There's not enough data. What happens if it triggers? and what they struggled with really up until the last, I'd say, year and a half, 2 years, is that too bad. It's like if the regulators want it, like, why fight it? There are other methods. Anytime you see a standard, whether it's the weather or the parachute standard, you'll see the regulator say this is an accepted means of compliance, but not the only. And then it's not everyone, it seems a lot focused on, well, what's the other ways? And then they realize it's a rabbit hole. Yes, there's other ways to get around it if you really want to get into it, but it's far more expensive. And so, whether that's going for like DO 178, DAL C, DAL B, whatever you want to do, and move up those chains. And so I think a big piece is just accepting. And, we look at the automotive industry, people hated catalytic converters, maybe the big manufacturers didn't even want it. And there's some good movies on that. And then there's like airbags and seatbelts. I think seatbelts were mandated in Texas in like the 90s finally. And it's one of those ones or helmets in motorcycles. Imagine that topic. So it's one of those ones where I think the big challenges is more like, technically, I think we're getting there as an industry. The ones that had very bad parachute system, flight termination system, they're not really existing anymore. And the ones that still do with bad systems are kind of not getting the larger deals that make a sustainable business. And then I think ultimately the challenges we see are more about implementation now. I think we're jumped over the hurdle. I don't think we have the same problem as like weather, where people are still trying to get to terms with the 30%. I think they've come to terms with our 30%. It's just now about, do they have the cash flow? Do they have the budget? Do the manufacturers see the opportunity to go into that market?
Yeah, that's a good point, Josh. And I'm now curious to move on to Ian. Same question.
Yeah, and I think what Josh said, it really lines up with what we're doing here now, is basically the ASTM standard documents, the ASD standard documents in the EU, and even Japan all have very, very similar requirements for basically the remote ID broadcast module or standard remote ID implementation. So as a manufacturer, we've had to go in and spend months kind of deciphering the Bluetooth messages, the Wi-Fi messages, the means of compliance, and basically building a remote ID broadcast module that is up to the spec. So most recently, with our, let's say, with our ZRID Lite broadcast module, we're finding out new intricacies about the remote ID standard and about open remote ID that enable us to shift some things around to help kind of lower the cost for the modules, and also keep it compliant with the ASTM and ASD standards. So, right now, in terms of the standards documents for the rest of the world globally, things like Open Drone ID that really facilitated remote ID becoming standardized across the US and the EU. If everyone keeps following those initial standards that are set as the foundation across the globe for things like Open Drone ID, it'll really help set the precedent for global standardization for both remote ID, and as we get into BVLOS operations, how those drones can be digitally detected across the globe.
Thank you, Ian. Josh, I want to go back to something that you said relating to protocols and reliability. So what testing protocols do you feel are essential for assuring the reliability and effectiveness of drone parachutes and other flight termination systems in a variety of environmental conditions?
Yeah, that's a funny one. So depending on which country you're in, and apparently kinetic energy affects you differently. I didn't know this, but apparently a drone coming down in one country faster might cause less injury than in another country.
It's the Coriolis effect, obviously.
I guess so. I don't even know what that means, but sure. It sounds rational.
Easy on the science, Jason. Easy.
Sorry.
I can talk about kinetic energy, transfer of energy, but yeah, no, I think it's an interesting topic. So so I'm the technical lead of the ASTM standard for parachutes. I took over this summer. And one thing, we're as a company, we started, this standard didn't exist in 2017. It got published in 2018. We didn't get our hands on it until late 2018. And we said, okay, this is going to be our golden book on what we're going to do baseline. We don't even think it's enough, but you go, and there's so many manufacturers out there who fight and say, this is overkill, this isn't needed. And they go to Europe and say, well, M2 mitigation medium, I only need 30 activations, 2 flight tests. And I wouldn't sleep well at night if that was the case. We do the 45 tests, deploy the parachute, get the data, and then we're still running missions. We're doing ongoing testing programs. And I think this is where like the drone industry is at a really tough point where it's getting expensive to participate. But it's one of those things where it's like, I didn't know you could cut corners on safety. I didn't know you could just make that as an excuse. And we see this with many manufacturers now who don't want to play with the real game, in my opinion. They want to cut corners, they want it as light as possible. They argue the costs are too high. And it's like, I've spent the money doing it ourselves. No one paid our first few drones on DJI drones. We paid that all ourselves. We had to buy the drones. We had to do the testing, dropping 150, 200K. And it's one that, like, once you get good at it, once you figure it out, and like, I think this is where the industry is rolling into more of that automotive sector where you're doing subcomponent and integration, whether it's remote ID, whether it's weather. Like, you're not going to do complete vertically integrated unless you got really, really deep pockets and a lot of time. It just, the economics don't play out if you're trying to do everything yourself currently. And this is where I think, like with parachute and testing, like anyone who thinks ASTM F3322 is overkill, I laugh at them in my head. I obviously very polite. When I hear that, it's just, to me, it's like, I know it's expensive and I know it's a big hurdle. I'm not a fan of M2 mitigation medium. Now, when you can use the example of 30 activations, 2 flight tests, I have customers that want to do that, and we support them on that. We also push them to do more because we just don't feel comfortable ourselves. All our DJI products come out with ASTM F3322. Plus, we're doing more testing. And I think when we look at testing, like, you can fight it, or you can just, like, this is going to be an easier path. We've seen so many companies fight these standards and adoption, and they're not getting approval. So their customers they don't have customers. So I think that as a component manufacturer, you have to look and say, how am I going to help my drone manufacturer sell more drones? Because I make money when they sell drones. I want my customers selling thousands of drones. And there's costs there that we have to co-invest in, and we have to believe in each other and ultimately get the product to market and make money off units being sold. And that's where I think with the industry right now, there's still that pushback, and it's fair, right? Like, not everyone's got $100 million sitting in the account. And you want to do a parachute integration. Yeah, there's some companies that'll do it for 2K. You buy their unit, you can go and like have fun. I know what that's like. I know what, and we see these customers, and we're actually more in the game right now of firing customers, it seems, who want to cut corners, who don't want to spend the investments. And I think this is a thing where the industry is probably getting more mature. Like, we'll make decisions on, okay, we don't think this company's safe. They don't want to do the testing. They don't want to. And, very anti-capitalism. I don't want to serve this customer, but actually it is, because it takes me the same amount of time to integrate a parachute for someone who's going to sell 1,000 units as 10 units, hopefully. And so this is where, I think the industry has got this weird or certain experience where, like, we want all these standards, but not everyone's got budget, and there's got to be a strategy. You can't do everything. And the companies that choose not to do it, I respect, because it's like, hey, I don't even want to do a parachute. I want to do all the testing. I'm just going to not play in that game that's 20 to 30% of market opportunity. And that's fine. But if you're going to come in and try to do it, like, do it right, because we see this in Canada. Just a final rant and pass on is, in Canada, we've been doing flight over people since 2019. We just had a big audit by Transport Canada a couple of weeks ago, and 15% of drone models were removed for false declarations, because we have a nice self-declaration system. We finally look under the hood and we find out a bunch of people are cheating and lying. And it's one thing, and some people made administrative mistakes. Not everyone was a bad actor, but it's one that I think people tried to do it, cut corners, and like, it'll be interesting to see if they face the financial penalties. You're supposed to get up to $15,000 per model of false declaration. So this is ultimately, I think it's time to the industry to accept there's certain costs, and if it's a cost of doing business, like, it is what it is. Like, I don't know, like, you can't tell your staff not to wear hard hats on a construction site because you don't want to buy the helmets. It's one of those ones where, like, do the right thing. And so end of rant. Sorry.
Go ahead, Don.
I just want to say I'm listening to Josh, and I'm thinking one of the things I want to make clear about the weather standard is you don't have to necessarily have better weather data. It's a risk-based performance standard. If you want to fly using the current data that's available, just recognize that you're going to have more risk and more liability potentially down the road. And also, you may not get that flight time that I was talking about. So what we've done is we've created a standard that said, look, if you're going to use a better weather service or a better weather, if you want to use that, you don't have to use it. It doesn't cost you anything if you don't want to use it. But if you want to use it, we're saying that the service that you're going to use, we have a standard that they have to follow in order to report what their error rates are in their data sets, or understand what is going to be allowed and approved, a third-party weather provider. This standard is for us to say you're an approved third-party weather provider, and now you can purchase from us, or we can support a UTM, and you know that that weather's meeting that standard. That's what the standard's about. And the other thing I want to mention is that if you decide that you want to take your own weather data off your own drone and use that to fly yourself, you could do that. Nobody's saying you can't do it. I wouldn't recommend it necessarily, but because, there is science behind this, and everyone thinks weather's easy. They think, oh, I just throw a sensor up. And no, there's all kinds of problems with motion and rotor blades and all this stuff. The data you're getting off a drone that's a weather sensor data is not necessarily accurate. Now, it may be good enough for what you want to use it for, but we can't have you share that back into the system for other people to use, because we have to be able to quantify what that error rate is and what the risk is. That's what the standard's about. It's just protecting everyone if they want to use third-party weather providers and not just use the government data. I just wanted to make that point, Jason.
Yeah. And Don, I want to stick with this just for a second, because you've talked about the gaps that are currently in the models. We just talked about sort of like reporting. I had a conversation yesterday with someone, and gosh, this has been a common conversation about practical scalability. Mm-hmm. So in your opinion, related to that topic a little bit, like what are the current gaps in those the current weather prediction models, like the ones in UAV forecasts and the ones that like are kind of practically scaled, that are practical applied to drone operations? How do we address those gaps for BVLOS and autonomous operations?
Yeah, so UAV forecasts, any weather company out there you're using today is using standard 9-kilometer resolution model data, and their initial conditions that they're using to run that model, we don't even know what the weather is, so we have to use models to estimate it. And then we're putting it in a 9-kilometer resolution model. So the winds at 300 feet are not necessarily, they could be off 30%, 40%. I know people have seen that, because I mean, that's why I know there's a business case here, right? Well, you can deal with that, and you could do that on one-off. I'm just going to go out and fly today. And if you're not on a schedule, right? If you're not on a schedule and you're not trying to do high velocity drone delivery and you're trying to make money, you can get away with that. But if you're trying to scale your operations and you're trying to be efficient and you want to know my drone's going to take this long to get back, I have to recoup that. I have to give my customer some lead time on whether I'm going to have to cancel. You can't mess around. And I've been working with a lot of drone operators, and they are starting to see this, right? They realize that it's about efficiency. Weather data, better weather data is about efficiency. It's about reducing the uncertainty so that you can plan better and use your resources better and have better client reliability. And so what I'm saying is that there are ways to close that gap. The gap is in winds. The gap is in ceiling height. The gap is in visibility at BVLOS. The gap is in icing and cloud, which we haven't had to worry about yet because we're below 400 feet, but we will have to start worrying about that when we start flying remote heavier lift drones from regional airport to Israel airport. They're going to be flying at 1,000 to 4,000 feet, 5,000 feet. That's going to be, if you're in the north in the wintertime, that's icing zone, right? So how are you going to know if there's icing there or not? Today, we over forecast it because we have to be safe. So here's the thing. We could put sensors on tower. If we get 100 feet above the ground and we co-locate a wind sensor with another detect and avoid sensor, we got winds now above the ground level. We're going to get much better wind than you're going to get from that UAV forecast. We take that data eventually and we do machine learning and we start improving our forecast. It's just by having that little bit of data that we don't have today. Today, it's a guess, right? Can't validate it. You only know it when you get up there. So that's what we're working on, right? Getting more ceilometers out so we could see the cloud height more ubiquitously. Right now, you only get a cloud height at the airport. Everything else a guess, right? If you're by a water source, if you're in a valley, if you're trying to fly in the morning and you don't know where the fog and stratus is, and the products you're looking at are not telling you if it's there or not because they don't know. They think it might be there or they think it might not be there. But what you see on a visualization is not real. It's a simulation of what we think is there because there's no measurements. So that's what we're trying to do.
No, Don, I appreciate that. So, yeah, go ahead, Josh.
I think one thing Don said that I just want to follow up on is you don't have to participate. Mm-hmm. You don't have to go to college. You don't have to go to university. You don't have to do a master's degree. You don't have to go do a PhD. You don't go to law school, med school. Those are choices. And if you want to play in certain opportunities, it's a cognitive choice. Anyone who thinks that I have to do all these things to run a drone company it's no, you don't have to buy it, you don't have to build it, you don't have to integrate it. But if you want to meet regulatory requirements for 90% of drone operation opportunities, or 95, or if you want 99%, things get more expensive. This is just a reality. No one wants to charge you that as much as they have to charge you. No one wants to, make you do this testing. It's just become a very scientific requirement based off needing data, reliability, performance. And I think that's something that a lot of people in the industry need to come to terms with. Like, if I want to do drone delivery, there's a cost of doing business. I'm sorry. Yeah. So you don't have to, but if you want to, there's a ticket admission price. You can watch the hockey game at home, or you can go in person. There's a cost. Sorry.
No. This is so. I'm curious about this. So I'm coming back to you, Ian, but I want to go off of something that Don said about like spoofing and things like that. It's like, yeah, you could probably spoof the weather, and it's probably opportunities to do that. Jam it, spoof it. It's already simulated anyway. Walk outside, see what it's like. If you want hyperlocal weather, you walk outside, you see what it's like where you are. Like, that's what you can currently do. But like, I want to talk to us about this for remote ID. So like, what steps can we take to ensure that like remote ID systems are resilient against jamming or spoofing? So particularly in like highly sensitive or highly regulated airspace.
Yeah, so for remote ID, it is built on an ASTM standard that is pretty much publicly available with the Bluetooth and Wi-Fi information that is broadcasted via messages. So I was doing some more research on exactly what we can do to combat this, or what the legal implications might be for somebody who does perform a spoofing operation. So basically with remote ID, I mean, you've got all of the drone registration information and all the remote ID identifiers live on the FAA's website and EASA's website, kind of publicly in CSV files. So it could potentially be a big problem. The FAA's perspective on this is you have 3 different 3-letter agencies that would get involved if there was a spoofing attack on sensitive infrastructure. So that would firstly be the FCC, who controls the radio frequencies. Well, they can't necessarily control what is being broadcast on those radio frequencies. If it's causing safety concerns near infrastructure, that would definitely imply legal action, especially if it's prohibiting or inhibiting on the safety of aircraft. I mean, that's when the FAA gets involved. And like just this week, one of the drone pilots in Florida who shot down a drone got sentenced to 4 years in prison. So, I mean, the FAA is taking this seriously, and it's not like you can really mess with the airspace and not have any implications. And then the last 3-letter agency that gets involved is the FBI for the actual like criminal, basically sentencing of the individual who performs one of these spoofing attacks. Like, let's say like thousands of remote ID broadcast signals coming out of a single stadium, something like that. So you would have all 3 of those 3-letter agencies involved. And from watching someone from the FAA talk about it earlier today, they said it's probably not a good idea, or he wouldn't recommend it based on that.
Okay, well, fair enough. So let me move back to a more generalized question. And we talked about this a little bit, but I want to double click on it a little bit. So we all know sort of the concept of this entire, the theme of this entire NestGen is that we're now looking towards evolving scalability and evolving standards. So in that context, so how, and I want to go to each of you on this, how can those global standards be designed to remain relevant and adaptive to new advancements in BVLOS operations? Let's start with Josh on this one.
It's got to be, there's a balance of what you need to do. I like the European low, medium, high, even though I don't think medium's good enough, but as far as their testing criteria in our small world. I think one thing with these standards is evolving, but it's also giving predictability. I think one thing drone manufacturers really want is like, if you're updating a standard every year, it's like, come on, guys, like let it roll. Like if there's clear issues, there's clear gaps, and people are cheating. We saw it in our parachute standard -18. People were using too much legalese to get smart and try to circumvent certain things. And the FAA caught somebody and made them redo testing. And it's like, so there's those elements that you got to tighten up. But like, I think ultimately the drone industry needs predictability. It's already tough enough with regulatory uncertainty. If we have standards, we need to get them out there for a few years, let them play out. I know one person in our standards body is like, really pushes that, the enemy of what is it? Enemy of great is good enough, or whatever the saying may be. But basically, yeah. Sorry, my brain works. But ultimately, it's like we have to accept some flaws. Humans are writing these standards. There's not some chatbot that's perfect that's doing it, or ChatGPT. So like, to me, it's like we need to accept that there's going to be always gaps, and we will get better slowly. But we also need predictability. People don't need things changing every year on them. So I think that's a big thing about standards and standard bodies is, yes, we can always get better, but like, do we need to do it every single year? No. Because like a drone manufacturer builds a drone, they want it out there 5, 7, 10 years to recoup their investments. Not everyone innovates at the DJI speed, obviously, and can pump out every 3 to 4 years, especially like, non-DJI companies will say. So it's something that like we need predictability and standards. And if we're changing things, this is just going to be, the 20s are going to be a year of just up and down. Like the more predictability we can give, the better I think we will be as a manufacturer, as a component manufacturer, as pilots, and as standard participants.
Thanks, Josh. Don, same question.
Yeah, no, I think one of the, weather's hard. I don't know if people understand this. Weather's hard, right? So uncertainty that we have in weather today, we don't know if it's being spoofed or it's just a bad forecast. You don't know that. And so it's hard for us to even discern what's happening because we don't know, right? We have to go back and trace it back and go, is this a bad forecast, or did somebody do something somewhere in the system? Now, in terms of the standard scaling, we said, look, this is hard. We got to figure out how to use these sensors that are not as expensive. We're saying right now the choice at a heliport today is a windsock or a $500,000 surface weather station. That's not a choice. All right. So what happens? We get a windsock. Guess what? A windsock is not as safe as one might think for a vertiport, especially for planning. How do people know what the heck the winds are there if they're not standing on the vertiport? I mean, it's the most ridiculous thing I've ever heard in my life. So we went back to the FAA and we said, look, let's find a way to get a $30,000 sensor that does all those things that a ASOS does at a vertiport. So people can actually have reliability and predictability about what's going on to make better decisions on whether or not it's safe to do a medevac into an urban canyon where you have people on a helicopter that, you have to decide if you're going to fly them or you're going to have to go out there with a car, right? Or an ambulance, which takes longer, right? These are the things that weather causes in the disruption. So we got them to agree. Yes, we got to use common sense. And we talked earlier about how hard that is sometimes, but we did it. And now what we have is a standard that's a start, and that's scalable. But it doesn't mean that we're going to get all the way there on implementing the whole thing at once. There's remote sensing data that comes from radar and satellite that is not the same as in situ measuring, like a thermometer. We have to figure out what's the area coverage that sensor is going to be allowed for you to use. Weather doesn't work that way. People always ask me all the time, hey, Don, that sensor at the airport, how relevant is it? What area does it cover? And you know what I tell them? I can only guarantee you it's where the sensor is. Everything else, if it's relevant or relevant to other areas around it, it's just luck because that day the weather happens to be homogeneous, right? But I've been on airports where half the airport is fogged in, the other half is 7 miles visibility. I don't know, right? This is the challenge that we have. So we got this standard to a point now where we have something like you said, Josh. It gives you an idea of what you could do and what's approved, and you can start going in that direction on certain things. But we're going to make it better. We're going to make it better. And we also have to move into the forecast elements. But it's scalable, but we're going to learn. But we're not going to change fundamentally the standard. We may just reduce some of the standard, some of the rules and the means of compliance. We'll try to make it, we have to make it feasible, right? And it may happen over time. It may not happen all at once. So I think that's my answer to that.
I appreciate that, Don. No, like I said, I think this is really interesting because there's a lot of, and then Ian, I want to get your thought on the same question. These are supportive technologies that help the industry, that help these operations scale, and they're required for a large number of these applications. And it's just trying to come to terms with that. So just want to make that small comment. I know we're sort of getting down to the end-ish. We're going to allow for questions right after we hear from Ian. So put them in the Q&A section. Hopefully we have a couple great questions for the panelists. Otherwise, I think I have at least one more. But Ian, your answer to this question.
Yeah, so speaking about like evolving regulations, especially about remote ID. So as I mentioned previously, remote ID was split into two systems, the network-based remote ID system and the broadcast-based system. The network-based system is really NASA's vision for a fully functional unmanned traffic management system with beyond visual line of sight operations. So those 53,000 comments on the NPRM for the remote ID rulemaking did convince the FAA to take out the network-based remote ID standard for now, but they did say that the network remote ID standard is something that's still on the table as a possibility for getting implemented in the near future to help enable BVLOS. So with the network-based requirement, I mean, you can imagine like every single drone basically via a UAS service supplier sending their data to a central FAA database so that in real time we have information on every single drone that's operating in the U.S. airspace. So while this is something that's coming probably around the corner and maybe something that happens somewhat parallel with the BVLOS rulemaking, this is just one of the things that the FAA has said that, hey, these regulations are not necessarily set in stone. They're designed to evolve and adapt based on the technological advancements. Although it may be lagging behind, it still has the ability to adapt and evolve based on how the technology evolves.
Thanks, Ian. And we did actually just get a question. So let me read this out, and whoever wants to take it, absolutely. So, okay. So I'm a UAS pilot. Yes, I am a UAS pilot for BVLOS medical delivery operations in Romania, doing long-range flights, 100 plus kilometers. We're in a constant conflict with the ATCs. We never have priority in the airspace, even if we announce the flight early. How do you foresee this situation evolving in the future? How fast do you think ATCs will adopt using network RID for airspace management? Actually, let's go to Ian since you're the. Actually, you know what, Josh, go. You raised your
quick response on that one is, I think what we've seen in the drone industry is countries where regulatory adoption and accepting drones as a real thing have created economic wealth that the country wants. And I think that eventually they'll come to terms that drones are as equal to crewed aviation. I think that's the piece. Like whoever wants, whatever country determines, you know what, drones are a good thing, crewed aviation's a good thing, let's play nice. I feel like that's like, if someone could get over that mindset that drones are second tier citizens, like that'll just change the game.
Awesome. Ian, love to hear your thoughts on that. Thanks, Josh.
Could you say again the country that they said they were operating in? Romania. Okay.
Have you been there?
An EU country? Do you guys know?
Yes.
Okay. So, yeah, and I guess in the EU, they do have the direct remote ID standard, which is very similar to the remote ID broadcast standard here in the US. And then they've also started implementing the network-based standard for the specific category of operations, some of those more advanced operations. So, I mean, that is also, I think there's a parallel here to Lance in the United States, where drone pilots were able to operate within 5 miles of airports with immediate authorizations if the air traffic control or the tower accepted those Lance authorizations. So it was kind of a phased approach. Initially, it was mainly like class Bravo, class Charlie, some of the bigger airports. And then after 2 years, they actually did another kind of rollout to a lot of the rest of the airports. Like, for example, for about 2 years, I still couldn't fly within 5 miles of the St. Petersburg airport in Florida because it didn't implement LANCE yet, although the LANCE standard was already created. So I think with remote ID in the EU, it just got required on January 1st, and it's going to take a little bit of time for air traffic control and everyone to like fully accept and embrace it and start operating with it in mind for their local drone pilots.
I think we can go on for days and days and hours, but I want to be respectful of everyone's time. This has been a great panel session. Panelists, thank you so much. Your insights and expertise have absolutely come across. Obviously, you can reach out to the panelists. You could talk to them either through direct messaging or through their LinkedIn or through their websites. Highly recommend you do that. Thank you so much for this session. This has been amazing, and we will catch you on the next session. Bye now.
Thanks, gentlemen.